Section 6.2, Real Applications of Normal Distributions. In the previous section, we learned about the standard normal distribution, where my horizontal scale representing the z-score with my mean equals to 0 and my standard deviation equals to 1. While in a non-standard normal distribution, the horizontal scale representing x and mean and standard deviation can be any number. It doesn't have to be 0 and 1. To convert from a non-standard normal distribution to a standard normal distribution, we use this formula right here. Example 1. Heights of men are normally distributed with mean of 68.6 inches and standard deviation of 2.8 inches. Find the percentage of men who are taller than a shower head at 72 inches. So the height of men are normally distributed with means of 68.6 inches and a standard deviation of 2.8 inches. I have a graph of normal distribution. Everything on the horizontal scale represents the x value, which are the heights of men. My mean is 68.6 inches, and I want to find the probability of men who are taller than 72. 72 is going to be to the right of 68. And I want to find the percentage of men who are taller than 72. So taller than 72 is to the right of 72. So I'm going to look for this area right here. To use StatCrunch for normal distribution, we are going to click on Stat, Calculators, and choose Normal. In this problem, my mean is no longer 0. It's 68.6. And my standard deviation is 2.8. I want to change this inequality to greater than, and this number is 72. This is my answer. And I got 0.11231932. I am going to round to 3 decimal places. 0.112. And the question is asking for percentage, so I'm going to convert that into percent. Example 2. A survey found that women's heights are normally distributed with mean 63.7 inches and standard deviation of 2.2 inches. A branch of the military requires women's height to be in between 58 inches and 80 inches. Question A. Find the percentage of women meeting the height requirements. Are many women being denied the probability to join this branch of the military because they are too short or too tall? So first, I need to graph this. This is normally distributed with mean of 63.7 inches and standard deviation of 2.2 inches. The number on the horizontal scale representing the woman's height, which is my x. My mean is right in the middle, 63.7. The height requirement need to be in between 58 and 80. So this is 63.7, 58 should be on the left, and 80 should be on the right. Which means any woman with height between 58 and 80 will be accepted. Which means I'm looking for this area. On the second example, I am looking for the area in between. So I'm going to click on here. My mean is 63.7. My standard deviation is 2.2. I want to find the probability in between 58 and 80. This is my answer. And my probability is 0.995 to 1386. I am rounding it into 3 significant figures. And the question was asking for percentage, so I will convert this into percent. So it's about 99.5% of women meet the requirement. Are there many women being denied for the opportunity to join this branch because they are too short or too small? No, because the probability of women who meet the requirements is very high. Question B. If this branch of military changes the requirement so that all women are eligible except for the shortest 1% and the tallest 2%, what are the new height requirements? I have the same graph, the same mean, the same standard deviation. Now they want to change the requirement. Instead from 58 to 80, now they say that they want them all to be eligible except for the shortest 1%. So this is 63.7, which is the average height. The shortest 1% is right here. So this area is 1%, which is 0.01. And they also want to exclude the tallest 2%. So tallest 2% is in here. And the area is 0.02. And they want to know what this is. So I call this A and this is B. So I know that the probability that x less than A is 0.01 and probability that x is greater than B is 0.02. And my job is trying to look for A. For question B, I'm going to go back to the standard mode. My mean and my standard deviation are the same. My probability is 0.01. I want to change this into less than, and this is my A. This A representing the height of a woman, and in here they only use 1 decimal place. I'm going to round this to 1 decimal place as well. To find B, I'll just write down the relationship. Probability of x greater than B equal to 0.02, and I want to look for that B. To find B, I'll change the probability to 0.02 and convert that into greater than. This is my B. And I'm going to round it to 1 decimal place. So to exclude the shortest 1% and the tallest 2%, I can take any woman with heights from 58.6 inches all the way to 68.2 inches. Example 3. Assume that adults have IQ scores that are normally distributed with a mean of 95 and standard deviation of 18.4. Find the following. Round to 1 decimal place. I have a normal distribution. Everything on the horizontal scale representing my x, which is the IQ scores. Mean is 95 and standard deviation is 18.4. First, they ask for median. So in a normal distribution, mean, median, and mode are exactly the same. So because mean is 95, median is also 95, and mode is also 95. B, they ask for the first quartile, which is Q1. Q1 is the 25th percentile, which means it has 25% below and 75% above. So if I call this number Q1, I know that this is 0.25 and everything to the right is 0.75. and I want to find that Q1. For question 3b, I have my mean of 95, my standard deviation of 18.4. I want to find Q1, which I know the probability is 0.25. And I want to change this into less than. This is my Q1. So my Q1 is 82.589389. And the question is asking me to round to 1 decimal place, which is 82.6. To find Q3, I have the same graph, but I know Q3 is the 75th percentile, which has the 0.75% on the left and 0.25% on the right. To find Q3, my mean is still 95. My standard deviation is still 18.4. I'm changing this into 0.75, and I want this to be less than. This is my Q3. My Q3 is 107.41061. And I am rounding this into 1 decimal place. To find the IQR, I take Q3 minus Q1. And that is 24.8.